Hi everyone and welcome to this video on Python's decorators. What are decorators in Python? Let's have a look at this simple example. Whenever you have this @ symbol inside of your code, that's a clear hint for a Python decorator. In our case, our decorator is this function over here, and a decorator is a higher order function in the sense that it takes as input a function and it returns another function as output. It can be another function, actually, we're returning the same one for simplicity. The decorator is doing its own thing, and then it is applied on a function, which is also doing its own thing. And so let's see what happens when the function is being run. And to understand this output, we need to know that this @ symbol is actually a kind of syntactic sugar in Python. That means that this function, which is being decorated, is given as input to the decorator. So we get decorating the function first, then the function is returned, and so when it runs, we can see running the function in the console here. And in order to convince you that this is actually how the syntactic sugar works, let's have a look at how this implementation is analogous. So applying the decorator, as we said, to the function, and then running the callable that is created, that is returned from the decorator, gives us the same output. Decorators, though, can also return a different function with respect to the input one. So let's have a look how this works. And as you can see, the original function did not run, but the new function was run. And why is that? This is because the decorator returned the new function, so the original function name over here is just a reference to the new function, which is actually running. And this can be seen when printing the name of the original function. As you can see, it's the new function actually that it's inside of this name now, not the original one. A very important thing to notice about decorators is when they are actually run. So if we have a look at this snippet of code, you can see we have our decorator and it is applied to a function, but the function is actually not being called. But if we run this code, as you can see, the decorator did run. And this is because Python works this way. So whenever the decorator, the interpreter sees the decorator over a function, it directly applies the decorator to that function. To move on with our discussion and to get closer to a real use case of a decorator in Python, we need to consider closures first. So let's have a look at this snippet of code to understand what they are. A closure is a nested function in Python where the inner function has a variable which is outside of its scope, but which is not global. It is a variable which is inside of the function that nests it. So in Python, this is called a free variable. And the nice thing about this closure is that when we instantiate, let's say, our multiplier, creating a multiplier function that multiplies by 5 our inputs, this multiplier state is saved somehow in this free variable, which is bounded to the scope of this function, even if it's not inside of its local scope. And so when we multiply by 5, 2, we get the correct result, which is 10. And now, strong of our concept of closures, we can see a real life example of an implementation of a Python decorator. So as you can see in this example, what our decorator is doing is getting the function as input, and then it defines another function inside of it. And this function is doing something, and then simply runs the input function to the decorator, which is now our free variable for the wrapper. And it returns the wrapper. So what is happening here is at runtime, the interpreter gets here, it runs sleepy decorator with say hello as argument, and it returns the wrapper. So this function, the whole function that does something and run the function again. This is the usual pattern of decorators in Python. So they just return kind of the same functionality of the original function, but with some additional feature. And so in our case, the additional feature is just sleeping 2 seconds. So let's run this and see what it does. So time to take a nap, nap is over, and then it prints our greeting string. We can also apply multiple decorators to a function, like in this example. So in this simple example, the first decorator is appending 3 exclamation marks to the result of the function that it's given as input, while this reverse decorator is reversing the output of the input function. So let's see how this works. And as you can see, we get first the 3 exclamation marks and then everything is reversed. To understand how this works and why it works this way, let's think how the Python interpreter behaves. So the Python interpreters get here to the reverse decorator, which gets as input the result of the exclaim decorator, which is this wrapper that wraps the greet function. So the greet function gets first append 3 exclamation marks, and then the string is reversed to get our output over here. And now, as the final boss, let's have a look at parametrized decorators. The idea behind parametrized decorators is that you can pass some kind of argument to a callable here, which is then used as a decorator. So our decorator now must be actually a decorator builder, in the sense that, as you can see, this builds from our previous example, the builder returns an actual decorator. If you can recognize this, it's the same decorator we had before, but with the advantage that now the sleeping time is defined here as argument in the decorator. So let's run this code and see how it runs. It takes the nap. This time it's longer, it's 3 seconds. To briefly summarize what we saw in this video, we saw the decorator syntax with the @ symbol, then we saw the concept of closure and of the free variable, which allows us to develop real-world use cases for our decorators. Then we saw stacked decorators, and at the end, parametrized decorator. I hope you had fun and enjoy coding with your Python decorators.